now that we have the labeled data set in the format that we wanted, we have all the information that we need to start training the model. We're going to start with the tutorial that I've linked on the landing page. Go to other useful links and resources. It's the link that tells us to build custom vision object detection in Google Colab. We're going to use Google Colab to train this. Follow this tutorial, have a look at this tutorial. It's very comprehensive. They go into a lot of details about everything that's needed to from labeling images to all the way to training and validating the model. So we're going to follow it very closely, and we're going to make some changes along the way. The changes that we'll make, I'll put a link to those files on the landing page, and we'll refer to them in this video. But the vast majority of the tutorial, the vast majority of the walkthrough that I'm going to make follows closely this tutorial. So please go into this tutorial, and they already have a link to a Google Colab that you can follow and use as a reference. You can also make a copy and keep a copy for yourself, which is highly recommended. Okay, so now we're going to have a quick look at the notebook, and we're going to highlight the important features that we need to keep in mind in terms of stuff to keep in mind before training the model. The environment, setting the environment up, including downloading the weights, including testing and making sure that everything is working as expected before training. In addition to, especially because we're training our own custom model and we're doing transfer training, what we need to do is to change the configurations and set up the environment perfectly in order to have the most efficient training metrics for our system. And finally, we're gonna quick test on the model on test images, and we're gonna test the accuracy of the model. Okay, so setting the environment up, we're gonna make sure that we're on GPU. So we go to runtime and notebook settings, we make sure that it's on GPU. We're going to start with cloning the GitHub repos into our workstation, work environment. I think I've maxed out the GPU runtime. So it's going to run without GPU for me, but you should be able to run it as expected. So now it's just setting the environment up. We're making sure that we're using the latest Yolov4 weights, which are trained on the Coco dataset. So when the repos get cloned, it's going to show up here. We're also going to define a couple of helper functions, which are going to help us view the predictions on Colab itself, just because it doesn't have that natively included. So I got the GPU up and running, so everything should be running as expected. So what I'm going to do is now you can actually officially run it on test images, run the model on test images using the weights that we've just downloaded, and this is how it runs. You want to be in the Darknet folder, run the detector function in the testing mode using the specific configuration file, which is gonna infer on, and it has the specific configurations in Yolov4. So in our model, we're gonna change these two. And we're gonna have our own weights. So here it's the weights that we've just downloaded and the image that we're testing on. So we're gonna run this. This is what running it looks like. There's a lot of stuff happening in the background. It's going through the convolutional layers and stuff like that. And what it found out is the detection took 54.5 milliseconds, and it's detecting 3 objects with this confidence level. This is what it looks like. I'm going to run it again. Run this one again. So this is just showing what the predictions, what the image version of what we just saw, and it's just bounding the objects and confidently displaying the percentages of detections. In our system, what we're going to do is I put the majority of the files in Google Drive just because it's easier to integrate all of them into this. It would look like this. Now I have my drive here with all my files here, right on right in the Google Colab notebook. So what we're gonna do is there's you can go into but save everything in your drive, including images and test images and all of that stuff. What we're gonna do is we're gonna jump into the section where you can go through all of this. This is all useful information about detections and outputs and how you can save the outputs, run the model on multiple images, and how you can save all of those into JSON format, for example, or TXT, or any other export. You can do it in CSV and other outputs as well. This is the section that we want to focus on. What we have so far is our labeled custom dataset, which is you have access to, which is in my drive, and it's the course that I have is called this one. So what I have here is I've got the data set, the labeled images with that are used for training and testing are all here. What I've got is the custom configuration file, and we're going to go over that. What we also have is the object, the object.data and object.names. We'll go into more detail on what those are, and we're going to go over that as well. Okay, so we've got the labeled data set so far. You can go over all these steps. This is using the other methods that we've talked about, using, for example, Google's Open Images dataset. You can use, for example, Python to download like images about a specific class. So what you'd want to do is go into this, explore. Say, for example, you want to have aircraft in your detection, and you want, for example, the object detection. So what you'd want to do is use this Python script. What it does is it downloads the specific classes that you want. You can have multiple classes, and for example, this person has a vehicle and registration plate, and you're downloading 1,500 images from each class, and you're downloading them into a CSV. That means you're downloading the images and the labeled data, the labeled images, the labels for each image here as well. You can also download the validation dataset, and you can specify, for example, the type of folder that you want this data to be saved in. Usually validation images are about, depending on what you're training, 10 to 40% of what you're training. So this is pretty much in the same range. we've talked about this before, which is you want to make sure that all the labels that you have, for example, whether it's here or whether in other data sets or whatever you get your, even if you label it yourself, you want to make sure that the labels are in the Yolov4 format in our specific case. But in different training settings, different training formats require different formats. So make sure whenever you're labeling, you want to make sure that whatever your label fits whatever format you wanna train on, kind of thing. And then after you download it, this is what it looks like. And you want to make sure that so that there's also Python script for converting the annotations into Yolov4. So he goes through all of this. This is really useful. You go over it if you have the time. Thing. Yeah, and then this is the option that we went with, which is manual labeling our images, as we've seen in other in previous sessions. So this is moving your custom data into the cloud, which is what we have here, which is you want to make sure that the testing images and the training images are within the folders, like properly labeled, properly set up, and in the right folders. So you want to make sure that all this information is there, and this is just validating that this is what we have, which is it's going to the content my drive and the drone, the class, the folder that we're in right now, which is the drone images. This is drive, my drive, and it's the drone image. Right. And it's checking this folder. And if it displays properly, you're going to see something like this. And what we're going to do is we're going to copy this into our working session in Colab. So what this is going to do is it's going to copy this folder from our folder and testing folder into the working sessions, the Darknet working sessions data, so that we have all the folders and all the everything in one area. That will save you a lot of time rather than trying to figure out where you went wrong in your path, kind of thing. You can also download it as save it as zip files and do the same thing, unzip it here. Copying is pretty much doesn't take that long. Okay, and the first time so now we're looking at the configuration file for the training. The first time you start working with this, you want to make sure, so you download it first, and then you copy it into your whatever you want to save it as, into your Google Drive. You want to save it there, and what we're going to edit in the configuration file. So this is the files that you have access to, and this is what we're looking at. So what you want to do is open it in text editor. You can do that as a part of the Google Docs, as a part of Google Drive. And what we're gonna do, we're gonna focus on a few things. You want to make sure that you've got the proper setup for transfer training with the input images. You have the option of starting with higher image dimensions. The number of channels that you have, for example, you may have different, you may have an RGB type of image, you may have a multispectral, you may have grayed out black and white type of image, and this determines the number of channels that you have in the image. So you want to make sure that you've got that right. Saturation, exposure, hue, all of that is by trial and error, depending on your specific data set. Specific custom model, you may want to change some of these parameters depending on your specific data set, but in our data set, we don't have, for example, multispectral images. We don't have grayscale type of images. We just have regular RGB. So we want to keep the same, for example, layering rate, saturation, exposure, and all of that. The thing that we're gonna change here is the number of batches and number of steps. So this depends on how many classes you have. You want to set the maximum batches depending on the how many classes you have. And for example, the number of batches and subdivisions also depend on how much computational resources you have. You may want to try out different options, but keep in mind, for example, that um, some of these parameters are, for example, can be only multiple, like for example, the dimensions can only be multiple of 32. You can start with, for example, higher dimensions, which requires more computational resources. So you want to make sure that you've got enough resources to run what you need to run. And the maximum batches, as we said, depends on the number of classes. There's a not necessarily specific formula, but it's just a recommendation that you can use to make sure that you've got the appropriate number of steps that you need to do to make sure that you've got the optimized learning rate, and how it kind of converges to the minimum error. So make sure you go over through all of this. I've made sure that all of these are I made these changes into our file, so you can depending on how many classes you've decided to train, you may want to change your own, but I will go into the number of classes that I've trained on, and my specific configuration file and object.data and object.name are going to be specific to the number of classes that I've trained. Yours might be different, so you want to make sure that you want to change your configuration file depending on the number of classes that you've trained on. So you want to make sure that after you've made those changes into your configuration file, you want to copy it into your Darknet folder, and this is what we're going to do. We're going to upload it from we're going to copy it from our folder there into this one here, and this is what we're going to do. In terms of object names and object data, what they are, so object classes, object.names is the file that has the classes names into one specific file. And what that means is, for example, it's just literally the name of the class that you've trained on. And in this example, for example, they've got animal names. You want to make sure that you've got the right format here. What that means is you don't want to have spaces, you don't have characters that do not interfere with the training process. So for example, you cannot have spaces, you cannot have like apostrophes or anything like that. Just make sure that it's one letter. Just make sure that it's one word. Convert spaces to underscore, etc. So make sure that it has all of that stuff. Object.data is essentially telling the model where it can find the training data, the validation data, the names of the classes that it's training on, and where it needs to save the backup as it trains. So as it trains, it creates automated, or like it kind of auto saves each training batch into await every 100 and every 1000. So I've got these already as well. This is what I have, making sure that it's I've got the syntax in the right order. I've trained on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 classes, and my configuration file including number of steps, the maximum batches. This is the optional step that I also did, which is change variable from 1 to 0 depending on the computational resources that you have and how fast you want the model to train on. So I'm copying these folders here. As we said, these are the classes that I'm training on, and this is the my object.data, which is I have my training in this specific folder, my validation in this specific folder, names, the classes names are in this specific folder, and the backups are, I'm saving it directly to my Google Drive. This is one of the advantages of connecting your Google Drive to Google Colab, is that when it does backups, it automatically backs up the weights into a specific folder that you want. But you're free to choose whatever backup folder that you want. Okay, so we've got our 2 files here. You want to make sure that everything is here and everything is in path. Make sure that you want to generate these 2 Python scripts, making sure that it's got the image name, the image itself, the image itself in the correct format, the name of the image, and the classes or the labels for each specific image in the right format, and all of that. So you want to do that for the training images and the test images. You want to make sure that all of that is here. Let's see if all of these files that are needed for our training are there. You want to make sure that this is text and train.txt are there. You want to have some test images, but you don't have them here. You want to have the object folder, object and test folders, which have your labeled data sets here. Yeah, you want to make sure that you've got also the object.name and object.data. I forgot to put them here. So this is why we do checks like that. So they're here. All right, cool. So this is everything that we need. So this is what we talked about with the transfer learning. What that means is we're going to start our training from a specific point using another convolutional layer, and we're going to take the optimized version of that layer or that system, and we're going to apply it to what we have here. So we're going to start training using the pre-trained weights from there. And ideally, you'd start training, not training. I've already been training my weights for quite some time. I think I have something like 8,000 iterations or something. If you're starting for the first time, you wanna train your model. This is where you start off. You run this cell and it starts training. And ideally, what you want to do is you start with the maximum loss and have the model converge eventually into the minimum loss. We're going to go over that in a bit. With the specific YOLO framework, you have the option of training where you left off, kind of thing. So as I mentioned earlier, when you create that backup folder, it creates autosave function. It creates like autosaved weights every 100 iterations. This is what we're gonna do. But before we do that, let me check our mean average precision of our model so far. So as expected. So yeah, for some reason it didn't detect the first time. what we're training on is 14 classes, as we saw in the object.names, and this is the precision for each class, um, precision precision percentage. For example, for deciduous trees, it's the average precision is 73%, coniferous trees 82%, basketball court 33%, tennis court 0%, park bench is 72%, etc. What that means is means different things for different classes. This is relatively low still, but it's higher, for example, than 33% or 0%. These are low because if you go through the data set, our data set, we don't have that many training courts labeled, tennis court labeled in our data sets. What it's saying is that we need to add a lot more data to our data set that includes tennis courts, labeled tennis courts, and labeled basketball courts, etc. For classes that have relatively higher, but still low, relatively higher precision values, it needs to train more to see if we can converge eventually and have higher precision percentages. But if you see this number lingering, so if you train for like thousands of iterations and this number is kind of lingering towards a percentage that's still kind of low, you need to add more training images, or you can change the configurations in the configuration file that we went through. So what I'm gonna do is I'm gonna train more on my data set, and this is what we're gonna do. So this is what it looks like when you continue on. It looks at it loads the architecture for the convolutional layer, and it's gonna start with it's gonna start reading it. And now I'm at my 13,000 iterations, 13,400 iterations. As you can see, the average loss is about 0.49. We want that number to be substantially lower. So this is why we're training for that long. And the other thing that you want to note is the number of hours that it takes for the model to finally converge. If that number is high, that means we need a lot more data to train on. Well, not necessarily a lot more, but enough more for the model to understand. So here in our model, we don't have enough data, for example, to what we looked at, for example, tennis courts. And this is why it's going to take kind of forever to converge. But if we have sufficient data for the classes that we want to train on, this number would be substantially lower. So in Google Colab, you want to make sure that you keep this session running by making sure that you keep interacting with the notebook, because if you don't interact with the notebook intermittently, it's going to assume that you've left it. And I think there's a period of half an hour that if you don't interact with the notebook, it assumes that you've kind of left it and it deletes all these files, kind of thing. So you want to make sure that you're interacting with this regularly, but also there's a limit on how many GPU hours you can use in a day, and this is why we had the GPU thing earlier on, which is I've used up I think 12 hours allocated to a daily, I think it's anywhere between 8 hours to 12 hours a day that you're allowed to use free GPU, which is more than enough in our case. But I needed to train for a lot more, and this is why you just wait for the next day kind of thing to use additional GPU.